we are going to discuss about alkynes and aromatic compounds. I'll try to finish this one today. Okay. So first of all, we'll discuss about here alkynes. So what is meant by the alkynes means here, which we can call as alkynes means the hydrocarbons which contain C triple bond C is called as alkynes. Okay, the hydrocarbons which contains carbon is called as alkynes. Okay, what is the general formula of the alkynes means CnH2n minus 2. What is the general formula of alkynes? CnH2n minus 2. So what is the suffix of the alkynes means? Y and Ne. The suffix of the alkynes is Y and Ne. Their IUPAC names are ends with Y and Ne. What is the simplest molecule in alkyne means ethyne. What is the simplest molecule in alkyne is here? Ethyne. What is the molecular formula of the ethyne is C2H2. What is the molecular formula of the ethyne means here? C2H2. So this also we can call as acetylene. This also we can call as here acetylene. Okay. So higher members are there. So their nomenclature could be there. Okay. And so what are the isomerism? The isomerism exhibited by the alkynes means alkynes are they exhibit as a chain isomerism, position isomerism, functional isomerism also. Which type of isomerism they exhibit as means here? Alkynes are they exhibit chain isomerism. Alkynes are exhibits chain isomerism, position isomerism, isomerism, and functional isomerism. So actually we may get the doubt, sir, how the alkynes are they exhibit as a functional isomerism means here they converted into dienes. Alkynes are they converted into dienes. Okay, how they are going to, that means here alkynes are they converted into dienes. Okay, dienes, they converted into diene. So what is the example for that one means here? For example, 2-butene is there. For example, this we can call as a 2-butene. So 2-butene is going to be converted into, so 1,3 butadiene. 2-butene is converted into 1,3 butadiene. Okay, so that's why iene is converted into one functional group to another functional group. So that's why alkynes are they exhibit as a chain isomerism, positional isomerism, and functional isomerism also. Clear? Next, the preparation of the alkynes. Preparation of alkynes. So how are you going to prepare as alkynes, ma? Preparation of alkynes. Preparation of alkynes. So how are you going to prepare as alkynes? So how are you going to prepare alkynes means first of all by the hydrolysis reaction of inorganic carbides also. Sir, what is the example means? For example, calcium carbide. The calcium carbide is it undergoes to the hydrolysis reaction. If the calcium carbide is it undergoes to the hydrolysis reaction means it forms calcium oxide plus acetylene. C2H2 is going to be formed. It forms as a calcium oxide and acetylene is going to be formed. Okay. And for example, if the magnesium carbide Mg2C3, Mg2C3 is it undergoes to the hydrolysis reaction to form as a acetylene, so propine. It forms as a propine and it forms as a 2 moles of the magnesium oxide and it forms as a propine. The molecular formula of the propine is CH3 bond C triple bond CH. So this is the one method we are using in the preparation of the alkyne. So what are the other methods we are using in the preparation of the alkynes means here? From vicinal dihalides and geminal dihalides also. For example, geminal dihalides I'm taking. For example, I'm taking as a geminal dihalides. So what is the example of the geminal dihalides means? CH2 bond Br bond CH2 bond Br. Okay, so this we can call it as a 1,2 dibromoethane. So when 1,2 dibromoethane is, it undergoes to the dehydrohalogenation reaction. What is the reagent we are using for the dehydrohalogenation? Means alcoholic solution of KOH. Alcoholic KOH. Okay, along with that one, so we can use as a sodamide. We can use as a sodamide. So sometimes in place of sodamide, they'll give as an excess of alcoholic KOH. If they had given excess of alcoholic KOH or excess of sodamide, also they form as acetylene. The molecular formula of the acetylene is HC triple bond CH. Okay, already we know the products here. So what are the byproducts? It forms means here KBr plus H2O. If you remove the 2 KBr, 2 moles, 2 bromine atoms, that it forms as a 2 moles of the KBr, and it forms as a 2 moles of the water molecule is going to be formed. Clear? And this is the one. And same reaction we can take from bisphenol dihalide also. So geminol dihalide. What is the geminol dihalide, Srijita? Geminol dihalide. What is mean by geminol dihalide? What is geminol dihalide, ma?
When the halogen atoms are present on the same carbon atom.
When the halogen atoms are 2 halogens are present at the same carbon atom, means that we can call as a geminol dihalides. If the geminol dihalides are treated with alcoholic KOH and sodamide, also it forms as a acetylene, HC triple bond CH. Okay, and same reaction. Let's see in this one. Here, if you are taking 1,1, 2,2 tetrachloro 2,2 tetrachloroethane. 1,1, 2,2 tetrachloroethane is treated with the zinc metal. If it is treated with the zinc metal, means it forms as here HC triple bond CH is going to be formed. Okay, acetylene is going to be formed. So what is the product it's going to be formed? It forms as an acetylene. 1,1, 2,2 tetrachloroethane is treated with the zinc metal, means it forms as a acetylene. Okay, and so what is the another reaction means here? When the acetylene HC, okay, so chloroform. What is the molecular formula of the chloroform? Means here Cl. If 2 moles of the chloroform is treated with the silver metal, okay, so to chloroform is passes through the silver metal. Okay, if it is passes through the silver metal, means it is also formed as here acetylene. HC triple bond CH plus 6 moles of the AgCl is going to be formed. Okay, it forms here 6 moles of the AgCl. Clear? Right,
Yes,
Mashrita? Okay, and so these are the different methods we are using in the preparation of here. So acetylene. And what are the physical properties of again? One more reaction is there. Using the pole-based electrolysis method. Sorry. Pole-based electrolysis method also we can use in the preparation of the acetylene. So for that one, what we are taking is we are taking as a sodium malate. What is the molecular formula of the malate? Means CH double bond CH bond COONA bond COONA. So this we can call as a sodium malate. Sodium malate. Okay, sodium malate. The sodium malate is it undergoes to the electrolysis process. Undergoes to the electrolysis process. If it undergoes to the electrolysis process, means it forms acetylene. It forms acetylene Na2CO3. Na2CO3. Okay, and it forms as here acetylene is the byproduct. Now we got the clarity. So all these are the different methods we are using in the preparation of the alkyne. Okay, next, sir, what are the physical properties of the alkynes? Physical properties. What are the physical properties? In this one, actually, except acetylene, remaining are colorless. So colorless and odorless. So acetylene only it is having some characteristic smell. Okay, acetylene is the colorless and it has the characteristic smell. It's there. Okay, so except acetylene, remaining other alkynes are there colorless, odorless. Okay, in that one, first three alkynes. First three alkynes are gases. Next eight alkynes are liquids. Okay, and greater than 8 are solids. Greater than 8 are here solids. Okay, first of all, here alkynes are less polar in nature. They are less polar in nature. Okay, if polar in nature means we can say, so generally polar molecules are soluble in water. Even though alkynes are less polar in nature, they are insoluble in water. Alkynes are insoluble in water. They are highly soluble in organic solvents. Highly soluble in organic solvents. They're highly soluble in organic solvents. Okay, right now. Here, they're highly soluble in organic solvents. In this one, next one. So what are the boiling point and melting point temperatures? Melting point temperatures and boiling point temperatures are increases by increasing mass. By increasing mass. And density also is going to be increases. So which one is going to be increases? Density also is going to be increases. Clear? So all these are the different physical properties we are studying about the alkynes. Next, chemical properties of the alkynes. Chemical properties. So what are the chemical properties of the alkynes? What are the chemical properties of alkyne? What are the chemical properties of the alkynes mean? First of all, so alkyne is more acidic. For example, we have here alkynes, alkenes, and alkenes. So which are more acidic in nature now? Suyuta, in alkynes, alkenes, which are more acidic in nature?
Alkynes.
Alkynes are more acidic in nature. How you are telling that alkynes are more acidic in nature? Because of in alkynes, carbon is exhibit as a sp hybridization. In alkenes, carbon is exhibit as a sp2 hybridization. In alkenes, carbon is exhibit as a sp3 hybridization. In this one, percentage of S character is going to be increases. Acidic strength also is going to be increases. And sometimes they're asking the question, in alkynes, alkenes, which one is more electronegative? Which one is more electronegative? So which are more electronegative means here, alkynes are more electronegative. Sir, how you are telling that alkynes are more electronegative means here? Because of their percentage of S character also is going to be increases. Percentage of S character is increases. One is acidic strength also is going to be increases, and the electronegativity also is going to be increases. Now we got the clarity here. So based on this one,
Yes, sir.
so right. So based on this one, we can explain acidic character of the alkynes. How we can explain the acidic character? So generally, if any acids, if they reacts with metals, means they releases the hydrogen gas. Okay, if any acids, if they reacts with any metals, means they releases the hydrogen gas. Similarly, in this also, if the alkynes, acetylene, HC triple bond CH. If it is reacts with the sodium metal, means it releases the hydrogen gas. Okay, and it forms as a sodium acetylene, C triple bond, C bond Na plus H2. Okay, so it releases here sodium acetylate and it releases the hydrogen gas. Okay, it forms as a sodium acetylate. And similarly, here only some tests are done. Okay, so what is meant by the Tollens reagent, ma? Tollens reagent. Sriyuta. What is mean by the Tollens reagent?
Sir, I don't remember.
But Tollens reagent is nothing but ammonical silver nitrate is called as a Tollens reagent. Actually, Tollens reagent and Fehling solution, Benedict solution, Schiff's reagent can be used the conformation of the aldehydes and ketones. Okay, so Tollens reagent is nothing but here ammonical silver nitrate. Ammonical silver nitrate. Okay, if the acetylene is, it gives the positive test for the ammonical silver nitrate. Okay, whenever it is treated with the Tollens reagent, it forms as a silver mirror. It forms as here silver mirror. Okay, so it gives us a positive test. And similarly, if it is treated with the Fehling solution, Fehling's solution, Fehling's solution. So what is the Fehling solution here? So alkaline solution of the copper sulfate, okay, and sodium potassium tartarate. Sodium and potassium tartarate and potassium tartarate. Okay, so alkaline solution of the copper sulfate and alkaline solution of the sodium potassium tartarate is called as a Fehling solution. In this one, alkaline solution of the copper sulfate is called as a Fehling solution A. This we can call as a Fehling solution B. Okay, so acetylene is reacts with the Fehling solution also, and it gives us a red color precipitate. So which color precipitate it gives us here? Red color precipitate. So what is the red color precipitate? Means it forms as a Cu, C triple bond, C bond Cu. That means two hydrogens are replaced by the copper metal. Okay, in the silver mirror also, two hydrogens are replaced by two silver atoms. In this one, clarity I'll give ma. So one more question I'll give here. If 2-butene is gives the positive test with the sodium Tollens reagent and Fehling solution, CH3 bond, C triple bond, C bond CH3. Is 2-butene is it gives the positive test with the sodium, either ammonical silver nitrate or Tollens reagent, sorry, Fehling solution. Either it gives the positive test ma. Sriyuta. It won't give the positive test because of there is no free hydrogen atoms. Is any hydrogen atoms are there but acetylene? Carbon-carbon
No,
triple
sir.
bond is attaches with any hydrogens ma? Is any hydrogens are there ma Sriyuta?
No, sir.
If it is no means it does not give the positive test with the sodium metal, ammonical silver nitrate and Fehling solution. So 2-butene it does not give the positive test for all the reagent. Got the clarity?
Yes, sir.
Right, ma. And here and directly I'm taking as a propine. Propine is symmetrical alkyne or unsymmetrical alkyne? CH3 bond C triple bond CH. First of all, the propine is symmetrical or unsymmetrical?
Unsymmetrical.
Very good. If it is unsymmetrical means addition of HBr for the addition of HBr for the unsymmetrical alkyne, addition of water molecule HBr, addition of water molecule. This we can call as a addition of HBr, addition of water molecule, addition of HBr and Hg plus 2 and H plus. In exam also they are giving like this only. In this one, oxymercuration and demercuration reaction. Okay. Now, all these reactions it involves in a electrophilic addition reaction. All these are involves in a electrophilic addition. Electrophilic addition means it follows the Markovnikov rule. What is the Markovnikov rule means here? In this one, the negative ion is attaches the carbon which is having less number of hydrogen atoms in a alkene. Okay, so less number of hydrogen atoms in an alkene or alkyne. That means here carbon 1, 2, 3 are there. 3 carbons are there. While having the 3 carbon atom, while attaching the water molecule, OH group is going to be attached to the second carbon. Then it forms as a CH3 bond, C bond OH, double bond CH2. Okay, double bond CH2. Now, the given molecule is stable or unstable means the given molecule is highly unstable. To become as a stable, it undergoes to the tautomerism. It undergoes here tautomerism. If it undergoes the tautomerism means it forms as a respective carbonyl compound and it forms as a CH3 bond, C double bond O bond CH3. So finally you got as here acetone. Finally it forms as a ketone is going to be formed. Okay. Now second one once you check it out. So HBr, if you add 1 mole of the HBr, Br is going to be attached to the second carbon atom only. Br double bond CH2. Double bond CH2. Again, if it is treated with 1 more mole of the HBr, if it is treated with the 1 more mole of the HBr means here in this one, let us say CH3 bond Br bond CH3. So that means here it forms as here geminol dihalide. Okay, when the unsymmetrical alkynes they react with excess of HBr. What is the final product means it forms as a geminol dihalide. And similarly this one also. Oxymercuration demercuration reaction. So finally what is the product you will get means you will get as acetone. Finally which product you will get as here acetone you will get. Now you understand? Okay.
Yes, sir.
Right now. Now here same reaction if you had taken addition of water molecule, that means BH3 H2 B6 in presence of tetrahydrofuran, and H2 O2. Sir, what is the product it forms means it forms as an aldehyde. CH3 bond, CH2 bond, CHO. Okay, the given reaction it follows the Markovnikov rule, anti-Markovnikov rule. In anti-Markovnikov rule, we are getting as a aldehydes. In Markovnikov rule, we are getting as a ketones. Okay, so in anti-Markovnikov rule, we are getting as a aldehydes. But in Markovnikov rule, we are getting as here ketones. Now you got the clarity here.
Yes,
okay.
sir.
Same reaction if you take means here if propane CH3 bond C triple bond CH. If it is treated with the HBr in presence of excess of HBr, in presence of H2O2, in presence of peroxide means what is the product it's going to form as here? According to the Markovnikov rule, you got as a geminol dihalide only, but you got as a 2,2 dibromopropane you got. So what is the product you got as here? So you got as a 2,2 dibromopropane. But whenever you are treating with excess of hydrogen bromide in presence of hydrogen peroxide, in presence of hydrogen peroxide means it forms as a 1,1 dibromopropane. That means CH3 bond, CH2 bond, CHBr2. CHBr2 is going to be formed. Now you got the clarity?
Yes, sir.
Okay, so all these are the different chemical reactions we are having. Okay, now along with that one, so we have some other reaction also. What are the other reactions we are having means here? So alkynes it undergoes to the reduction reaction. Let us see simply I'm taking as a butyne, CH3 bond, C triple bond, C bond CH3. So 2 butyne. With the 2 butyne it is reduced with nickel, platinum, palladium. It acts as a strong reducing agent. Whenever it is reduced with the strong reducing agent, means it forms as a butane. Okay, and if it is reduced with Lindlar catalyst, what is the Lindlar catalyst? Palladium in presence of barium sulfate. Palladium in presence of barium sulfate means it forms as a cis alkene. Forms as here cis alkene. And if it is reduced with sodium in presence of liquid ammonia, sodium in presence of liquid ammonia means it forms as a trans alkene. Forms as here trans alkene. So all these reactions we already seen in the preparation of alkenes chapter from the alkyne. Okay, clear?
Yes, sir.
Next. So what are the other reactions we are having here? Next. Alkynes are, it undergoes the polymerization reaction. Alkynes are, it undergoes the polymerization. So polymerization means 3 moles of acetylene is passes through the red hot iron tube. Through the red hot iron tube. When it is passed through the red hot iron tube means here it forms benzene. So what is the product it forms? It forms as a benzene is the product. Okay, clear? If it is taken as a propane, if 3 moles of the propane, if 3 moles of the propane, if 3 moles of the propane also it is passed through the red hot iron tube means it forms as a 1, 3, 5 trimethyl benzene is going to be 1, 3, 5. This we can call as a 1, 3, 5 trimethyl benzene. Trimethyl benzene is going to be formed. So this also we can call as a mesitylene. This also we can call as a mesitylene. Sir, what are the main importance of acetylene? Acetylene can be used, oxyacetylene can be used in a gas welding process. Oxyacetylene can be used in gas welding process. Okay, and what is another important point means here? Okay, and to ripen the fruits and all, they used as acetylene. Okay, to ripening of the fruits. So which one here? To ripening of the fruits, they used as a acetylene. Okay, so all these are the some different importance. At the same time, acetylene can be used in the preparation of the benzene, and it is used in the starting material to prepare as a large number of the organic compounds. Now we got the clarity. This is about acetylene. Next, we'll go for aromatic compounds. Aromatic compounds. So we already discussed what is with aromatic compound, what is with the non-aromatic compounds. Is it right now? Aromatic compounds. Aromatic compounds. So what is meant by the aromatic compounds and what is meant by the non-aromatic compound? Aroma means the pleasant smell. The compounds which gives us a pleasant smell that we can call as a aromatic compounds. So what are the characteristic properties of the aromatic compounds means here? Aromatic compound, they have to be planar structure. Okay, and conjugation it has to be there. Conjugation is nothing but they have to be alternate double bonds and single bonds. They have to be here alternate double bonds and single bonds, and they have to follow the Huckel rule. Which rule they have to follow, ma? They have to follow the Huckel rule. That only we can call as an aromatic compound. What is the best example, simplest example of the aromatic compounds means here? So benzene. So benzene is one of the best example of the aromatic compound. Benzene is one of the best example of aromatic compound. Clear? Okay. And what are the other substances are there? All those are we can call as a derivatives of benzene. Sir, what are the examples of the derivatives of the benzene means here? Chlorobenzene, bromobenzene, iodobenzene, toluene, carboxylic acid, benzoic acid, benzaldehyde, acetophenone, benzophenone. All these are we can call as a derivatives of benzene. All these compounds are we can call as a derivatives of benzene. Okay. Now let us see how we are going to prepare as a benzene. Preparation of the benzene. Now already we had seen two methods. How we are going to prepare as aromatic compound. First one, If the acetylene is passes through the red hot iron tube at high temperature, it forms as a benzene. Okay, and what is the another methods we are having means here? We have here first phenol. Phenol. Phenol is treated with the zinc metal. The phenol is treated with the zinc metal means it forms as a benzene. Okay, if the phenol is treated with the zinc metal means it forms as a benzene. At the same time, sodium benzoate, COONA. If the sodium benzoate is treated with soda lime, it is treated with here soda lime. Sir, what is meant by the soda lime means here? Soda lime is nothing but here it is the sodium hydroxide and calcium oxide mixture. It is a mixture of sodium hydroxide and calcium oxide. Okay, if it is treated with this one means it is also formed as here benzene. It is also formed as here benzene. So all these are the different methods we are using in the preparation of the benzene. Okay, and what are the physical properties and all means here? So benzene is insoluble in a water. Benzene is having characteristic smell. It is a colorless liquid. Benzene is here colorless liquid with the characteristic smell. Okay, so benzene is insoluble in a water. It is highly soluble in a organic solvent. Okay, and what are the chemical properties of the benzene? So benzene is it undergoes to the electrophilic substitution reaction, sir. Benzene is it undergoes to the electrophilic substitution reaction. Chemical properties. Benzene is it undergoes to the electrophilic substitution reaction. So what are the examples of the electrophilic substitution reaction means? Let us see now. So first I am taking as a benzene. If the benzene is treated with the chlorine in presence of FeCl3, if it is treated with the chlorine in presence of FeCl3 means it forms as a chlorobenzene. That means one hydrogen atom is replaced by the chlorine. If one hydrogen atom is replaced by the chlorine means that only we can call as a chlorobenzene. Okay, and if it is treated with the nitration mixture, what is with the nitration mixture means? Nitration mixture is nothing but it is the mixture of concentration nitric acid and concentrated sulfuric acid. Concentrated sulfuric acid. If it is treated with the concentrated sulfuric acid means it forms as a sulfur benzene and nitrobenzene NO2. This we can call as a nitrobenzene. If it is treated with only concentrated sulfuric acid, if it is treated with only sulfuric acid means it forms as here benzene sulfonic acid. Benzene sulfonic acid is going to forms as here benzene sulfonic acid. Have you got the clarity?
Yes, sir.
Okay. Right. Again, it involves in a Friedel-Crafts alkylation reaction. So what is the Friedel-Crafts alkylation reaction means? If it is treated with the methyl chloride in presence of AlCl3, it forms as a toluene. Forms toluene CH3. Okay. Here, if it is treated with the acetyl chloride CH3, C double bond O Cl. In presence of AlCl3, it's also formed as here acetophenol CH3, C double bond O bond CH3, C double bond O CH3. It forms as a C double bond O. This we can call as a acetophenol. Okay, that we can call as a acetophenol. Okay, and again it is reduced. It undergoes to the reduction reaction. It undergoes to the reduction reaction. If the benzene is it undergoes to the reduction reaction in presence of strong catalysts, in presence of strong estate, either it may be nickel, platinum, or palladium. It forms as a cyclohexane. So what is the product it is going to form as here? It forms as a cyclohexane is going to be forms as a cyclohexane. Okay. At the same time, if it is treated with excess of chlorine, the benzene is treated with excess of chlorine in presence of sunlight. It forms as a benzene hexachloride Cl, Cl, bond Cl, bond Cl, bond Cl, bonds here. So this we can call as a benzene hexachloride. In short form, we can write as a BH3. And these also we can write as a triple six. And these also we can write as a lindane. And these also we can write as a gamaxine. Gamaxine. Okay. So already we know what is the gamaxine. Is it right or not? Where we, for which purpose we can use as a gamaxine, gamaxine powder? For which purpose we can use gamaxine powder? See it up.
Pesticides or like
Pesticide to kill the ants and all. Even in home also we can use that one. Okay, so gamaxine powder can be they used to spray. Okay, so powder placed on the rice bags and all. Okay, so all these are the different chemical properties of the benzene. Okay, now we had seen now. So this is about here aromatic compounds and all. Now we got the clarity.
yes, sir.
Okay, clear? So remaining part will continue tomorrow. So tomorrow I'm going to start 12th portions. 12th, which one I'm going to be start means here interlinked chapter, aromatic compounds only, haloalkanes, haloarenes I'm going to be start.
Okay, sir.
Okay, ma? Right. Okay, so we'll continue by tomorrow. Okay, and here only one concept it is that here only I can finished. So what is the concepts means here? Is haloarenes are it undergoes to the electrophilic substitution reaction. Why they undergoes to the electrophilic substitution reaction, ma? Do you have any idea about that? Haloarenes.
No,
You don't have any idea about that one. Huh? You're not having any idea, ma?
no, sir.
Okay. So then tomorrow I'll explain clearly all points and all. Tomorrow I'll continue. Okay.
Okay, sir.
Thank you, man. Until here, just you check it out. Okay. This Sunday you have a test based on this chapter, full chapter. Otherwise, I can give day after tomorrow only test. Better you
Yes,
write
sir,
the
that's
test based
fine.
on day after tomorrow.
Yes, sir.
Full hydrocarbons. Okay.
Yes, sir, that's fine.
Okay, right, man. So then after within 2 days, we are going to within 2 to 3 days, we are going to come within 2 days only. So we are going to complete the haloalkanes, haloarenes. So that time we can write the test again based on that. Okay.
Okay, sir.
So I'll try to finish by this month and as early as possible. Okay. Right. We'll continue the next class.
Okay, sir. Thank you, sir.
Welcome.